December 1933 arrived along Lake Erie with gray water stretching toward a pale horizon. Light snow drifted across dock surfaces in Cleveland, Toledo, and Buffalo. Freighters continued their movements through shipping lanes, their hulls dark against the winter sky. Port cranes turned above stacks of cargo. The routine of winter shipping continued. Lake Erie functioned as industrial infrastructure. Shipping lanes connected the iron mines of Lake Superior to steel mills along the southern shore. Coal moved from Pennsylvania fields through Erie and Cleveland, bound for northern ports. Grain traveled east from the prairie states. The lake carried over 35 million tons of coal annually during this period, nearly 10% of United States production. Loading rigs in Toledo and Cleveland could fill a 10,000-ton vessel in 10 to 12 hours. Power plants drew water from the lake for cooling. Cities depended on continuous supply chains that winter had always interrupted, but never stopped completely. This was the expected winter. Shipping companies knew ice would form. Ports prepared for reduced schedules. The lake froze partially most years, and by January or February, navigation became difficult. But it was manageable. The system accommodated winter as a factor in operation, not a threat to existence. Ice formed late in November in the western basin, where depths averaged only 25 to 30 feet. The eastern end remained navigable longer due to greater depth and the current from the Detroit River. Freighters worked until conditions forced them to halt. This was December 1933. Winter operations were underway. The meteorological pattern established itself over the Great Lakes region in late December 1933 and held through February 1934. Arctic air masses descended from Canada in sustained outbreaks, each lasting several days. Between these events, temperatures did not rise sufficiently to produce meaningful thaw. The normal alternation of freeze and thaw did not occur. Instead, cold accumulated. Lake-effect snow fell repeatedly. Cold air moving over the relatively warmer lake surface generated snowfall bands that deposited snow across shoreline communities. Each storm added to accumulation. The lake itself cooled steadily. Surface water temperatures dropped through December. Ice formation began earlier and proceeded faster than typical years. By early January, ice covered the western basin and extended eastward. Clear ice formed first in calm waters, homogeneous and several inches thick. Slush ice, broken ice mixed with snow, packed into harbors and against shorelines. Wind-driven ice sheets consolidated into field ice that stretched miles from shore. The ice did not stop. Each night brought temperatures well below freezing. Each day failed to reverse the process. Records from February 1934 document sustained extreme cold. In upstate New York, temperatures remained below zero for extended periods. The harbor at New York froze. Lake Ontario froze over for the first time in 60 years. In Cobourg, Ontario, Captain Charles Redfern of the Ontario Car Ferry No. 2 recorded temperatures of 30 degrees below zero Fahrenheit on the bridge of his vessel. He stated ice was at least 4 inches thick across the lake, and that even floating ice had congealed into a solid mass. This was not a storm. This was the absence of warmth persisting week after week. The cold was a constant force, and the lake responded by freezing. Harbor ice appeared first. In Cleveland and Toledo, slush ice thickened in protected waters behind breakwaters. The ice ground against wooden piers with a continuous scraping sound. Dock workers reported the texture changed daily as temperatures fluctuated slightly, but never rose above freezing for long. Within 2 weeks, shorefast ice extended hundreds of feet from land. Shipping channels narrowed. Captains reported ice thickness increasing in the main transit routes between Detroit and Buffalo. What had been navigable water became a field of broken ice sheets, some large enough to halt a vessel's forward progress. The ice did not simply float, it packed together under wind pressure, forming barriers that resisted penetration. By mid-January, ice coverage extended across most of the lake's surface. Measurements indicated ice thickness of 4 to 8 inches in open water, thicker in protected areas. The western basin, shallowest and coldest, became impassable first. Ice then spread east toward Buffalo and Erie, Pennsylvania. The lake's surface changed from dark water to white expanse. Temperature records show this period as one of relentless cold. The freeze was not dramatic. It was incremental and inexorable. Each day added to the total. Lake Erie, because of its shallow depth, froze faster than the deeper Great Lakes. By February, observations confirmed what dock workers and ship captains already knew: the lake was closing. The ice was measured, discussed, and documented. It was thick enough that reports circulated of people skating on protected bays. Captain Redfern stated that a dog could walk from Rochester to the Canadian shore if it avoided air holes. This was not anecdote embellished. It was observation recorded by experienced mariners facing conditions they had not seen in their careers. Ports closed sequentially as ice became impassable. Buffalo restricted operations first, followed by Cleveland, then Toledo. Icebreakers existed but proved insufficient. The Coast Guard cutter Escanaba, built specifically for Great Lakes ice work, operated throughout the winter but could not maintain open lanes. The volume of ice, its thickness, and its continuous reformation exceeded the capacity of available vessels to clear it. Car ferries, vessels designed with reinforced hulls to break through ice, struggled. The Ontario Car Ferry No. 2, commanded by Captain Redfern, battled ice during the week of February 5th through 9th. The crossing from Cobourg to Rochester and return required constant work. Ice extended farther from shore than any time residents could recall since 1918. The ferry's 318-foot reinforced hull, built to navigate 4 feet of ice, encountered conditions that pushed its limits. On February 10th, the cutter Escanaba freed itself from 10 inches of solid ice at its berth with a single backing movement. By contrast, 2 car ferries, the Grand Rapids and the SS Missouri, remained stuck 200 yards outside a breakwater, unable to enter harbor despite multiple attempts over several days. The Milwaukee Car Ferry waited days for weather, attempted departure, was stopped by ice for 2 days, then backed into harbor, refueled, backed out, and reached clear water only after 3 days of effort. Coal deliveries ceased. The 35 million tons annually transported by lake vessels did not move. Steel mills dependent on continuous coal supply idled sections of operation. Grain shipments halted. Factories that relied on lake-delivered raw materials adjusted production schedules or reduced output. The system that moved materials across the Great Lakes industrial region stopped functioning. Rail lines absorbed some freight but could not replace lake capacity. Congestion built at rail terminals. Costs increased. The economy, already depressed, absorbed another constraint. Lake Erie had frozen, and the infrastructure built around open water faced a condition it could not overcome: the lake solid. Cleveland, Toledo, and Buffalo encountered supply strain. Heating fuel stocks diminished as coal shipments halted. Coal moved by rail instead, but at reduced volume and higher cost. Power plants managed reserves but operated within tighter margins. The lake, which provided cooling water for generation, remained accessible, but the closure of shipping lanes meant fuel delivery required alternative routing. Docks stood silent. Snow covered cranes and loading equipment. The machinery designed for continuous operation sat idle. Work ceased for dock laborers dependent on shipping schedules. Employment, already scarce during the Depression, contracted further in port communities. Economic activity dependent on lake commerce halted for the duration of the freeze. Ice-locked shorelines. From the water's edge inland to the first streets, a white surface extended unbroken. In Buffalo, the harbor showed only a narrow shipping channel cleared between breakwalls, a sliver of open water in otherwise frozen expanse. In Cleveland, lake-effect snow had deposited over 80 inches for the season. The snow, combined with ice, transformed the lakefront into a landscape unrecognizable from its summer or typical winter appearance. Residents of port cities observed the phenomenon. Carol Nichols, living near Port Hope, recalled his father running from the barn in excitement. Neighbors were skating on the lake. The family went out that afternoon and skated on Lake Ontario, frozen solid enough to hold a person's weight in a bay that rarely froze. The night brought sounds unlike any winter, the roaring of ice, thunderous and continuous, as the sheet adjusted under temperature stress and wind pressure. The cities functioned but constrained. Rail replaced lake transport where possible. Stockpiles of materials were consumed. Factories adjusted. The freeze was not a crisis of survival but a systematic reduction of capacity. The infrastructure of the industrial Great Lakes operated under duress, waiting for the lake to release its ice. Ice exerted mechanical force on structures. When wind pushed ice sheets toward shore, the accumulated mass piled against docks, piers, and seawalls. Ice shove, the term for this phenomenon, occurred when strong winds drove field ice onto land. The ice did not flow like water. It compressed, stacked, and crushed whatever resisted its movement. Pressure ridges formed where ice sheets collided. These ridges, piles of broken ice pushed upward by horizontal forces, reached several feet in height. The formations appeared along shorelines and in mid-lake areas where wind and currents drove ice together. The ridges were not stable. They shifted with continued wind and temperature changes, exerting new forces on adjacent structures. Piers sustained damage. Wooden pilings fractured under pressure from expanding ice. Concrete seawalls cracked where ice pushed against them repeatedly. Water intakes for power plants and municipal water systems faced blockage from ice accumulation. Clearing these intakes required manual labor in dangerous conditions. The freeze-thaw cycle, even with minimal thaw, stressed materials. Steel expanded and contracted. Wooden structures absorbed moisture from snow and ice, then contracted when temperatures dropped further. Repeated stress over weeks weakened structural integrity. Damage appeared gradually: a tilted piling, a crack in concrete, a deformation of metal sheeting. Docks designed for summer use and moderate winter ice faced conditions beyond design parameters. The ice of 1934 was thicker, more extensive, and more persistent than anticipated. Structures withstood the forces, but not without cost. Repairs would be necessary come spring. The lake had tested infrastructure and found limits. Buoys designed to mark navigation channels suffered ice damage. Keeping them in position became impossible once ice surrounded them and began moving. Lighthouses and breakwaters received impacts from shifting ice masses. The clearing of ice threatening these structures became a continuous task for what limited ice-breaking capacity existed. Spring breakup began in March as temperatures finally rose above freezing for sustained periods. Ice cracked first along the edges where the shore absorbed solar radiation. Leads, channels of open water, appeared between ice sheets. The ice, which had been solid and immobile, began to move. Cracking sounds echoed across the frozen surface. Large sheets broke free and drifted with wind and current. The movement was slow initially, then accelerated as more water opened. Along shorelines, ice piled up in final shoves as wind drove sheets inland before they could melt. Debris, broken wood, displaced equipment, fragments of structures, lay strewn where ice had pushed it. Flooding risks emerged. The heavy snow accumulation and ice melted simultaneously, releasing water into rivers and streams faster than they could drain. Communities downstream faced high water. The transition from ice to water was not benign. It carried its own hazards. Economic impact became calculable. Shipping companies tallied lost revenue from weeks of halted operations. Ports assessed damage to facilities. The winter of 1934 had demonstrated vulnerability in the lake transportation system. Industries dependent on continuous supply faced questions about reliability. Lake Erie reached its lowest water level on record in the winter of 1934, 1.5 feet below datum. From July 1934 through June 1935, monthly low water records were set. The combination of reduced precipitation, increased ice cover preventing evaporation during cold months, and the extreme freeze created hydrological conditions unprecedented in recorded history. Port planning changed. Icebreaking capacity received attention. Winter shipping protocols were reassessed. The assumption that winter would interrupt but not halt lake commerce had been tested. The lake had frozen nearly solid. Navigation had stopped for weeks. The system had proven fragile. Water moved again across Lake Erie. Shipping resumed. Docks returned to operation. The winter ended, but memory persisted. The industrial cities of the Great Lakes had depended on water that turned to ice and held. The winter of 1933-1934 was not forgotten. It had been a winter when the lake became a surface, not a highway. When ice, not water, defined the conditions. When cold, sustained, and relentless closed a body of water that industry required to remain open.